Hi everyone. Today we're going to take a look at states of matter, but we're not going to be looking at the particles like we did last time. We're going to be looking at how their shape and volume is different. Okay. If you need to get a hold of me, my email address is on the screen. It's rcrawford@jcpsmail.org. Let's hop right in. In our last video, I shared, and some of you may have already known, that the way the particles behave in each state of matter is quite a bit different. In solids, we notice that the particles can only vibrate in place, and in large part, that is due to the fact that there is a very strong attraction between the particles still. So the particles are attracted to one another and they're locked in place, they're not very free. When we looked at liquids, the particles in liquids are able to rotate around each other, slide past each other, tumble over each other. Generally, they can move, but they stay clumped together. And the reason for this is because there is a weakened attraction. More heat energy has been added, it's weakened the attraction, and those particles are now somewhat more free. But there is still an attraction there because they stay clumped together. When we look at gases, those particles are going to be completely free. They have the most energy. They just bounce around at very high speeds. There is no attraction at all between the particles. Okay, so what these particles are doing absolutely affects how the substance behaves. Let's look at one more quick review. So volume, remember, is the measure of the amount of space that an object takes up. So clearly this uninflated balloon on the left takes up much less space, whereas the inflated balloon on the right-hand side takes up much more space. And so we can, in some ways, think of things as getting bigger or smaller. Those are all terms that are connected with volume. All right, so when we look at how when we look at the properties of solids, liquids, and gases, these different states of matter, two of the properties that we always focus on are shape and volume. And we'll try to tie that together here in just a moment. So first off, let's just agree that when we look at a solid, generally speaking, solids don't change shape and they don't get bigger or smaller. So both shape and volume tend to stay the same. When we look at a liquid, on the other hand, we know that liquids are shapeshifters, right? Liquids are able to flow, so they are able to change shape. But we don't suddenly have more or less of a liquid, right? So the volume will stay the same. So with liquid, the shape can change, but the volume will stay the same. With gases, we find that gases are a bit strange in the fact that they can both flow, they can change shape, but they can also change volume. Like if we take a tiny bit of a gas and we put it in a container like this, it's going to be able to get bigger, so to speak. In reality, what's going to be happening is those particles are going to be getting farther apart. So the easiest way for you to think about shape and volume is not the way that it's generally taught, I think. And so when you think about shape and volume, I want you to imagine that you've placed a sample or an object in a sealed container, and then what would happen? Okay, so when we place a sample of a solid in a sealed container, well, it's just going to sit there. It's not going to change, and that's really what happens. Solids do not change shape or volume. If we take a liquid and we put it in a sealed container, well, the shape is going to change. Liquids are going to take the shape of the container in the bottom of the container due to gravity. But there's not going to suddenly be more of it just because we've put it in a different container. So remember, liquids, the shape changes, the volume will stay the same. Gases, on the other hand, gases, you're going to have both the shape and the volume change. So if we were to take a tiny bit of gas and put it in a sealed container, those gas particles, because there's no attraction between them, are going to spread out and completely fill the entire container. So that's volume changing. And since we know it can flow, that's also its shape changing. So when you are thinking about the shape or volume change, I want you to imagine yourself placing a sample inside of a sealed container, and then what would it do? That is a very helpful way for you to think about it. All right, let's take a look at, see if we can connect what the particles are doing to the way a substance or an object is behaving. In other words, how do those states of matter and particle motion, how are they connected to each other? So with solids, If you'll remember, in solids, solids have very little heat energy. Now, very little heat, that's going to mean that they have the least particle motion. Okay? Because remember, heat is particle motion. The more we heat something, the faster the particles move. If we cool something off or remove heat, the slower the particles move. So little heat in solids means very little particle motion. Now, this allows those particles to stay really close together. And when they're really close together, remember intermolecular forces, that means that they're going to have very strong attractions between them. Those strong attractions are what cause those particles in solids to be locked in place, and they can only vibrate back and forth. So when we see a solid holding its shape, it is because of all of these reasons. It's because those particles have little heat, and there's very little particle motion, and the particles are then able to stay very close together. And then that closeness allows some attraction that locks them in place. All right, now what if we were to add some heat to a solid? Well, of course, the particles are going to move faster. When they move faster, those particles are going to begin to collide with one another. When they collide, they're literally going to push each other. They're going to knock into each other and push each other farther from each other. They're going to get farther apart. As those particles are pushed apart, remember, the intermolecular force, that attraction, weakens with distance. That's going to weaken that intermolecular force, and now those particles can move more freely. And voila, we have a liquid. Okay? So now let's think about what's going on with those particles in a liquid. The particles in liquids have some heat energy. We already know that they have more because to get it to change to a liquid from a solid, we had to add some heat. This increased heat means more particle motion, and that more particle motion means more violent collisions, which is of course going to push the particles a little farther apart. As those particles are pushed apart, that's going to weaken that intermolecular force. The attraction itself between the particles is weakened, and that frees the particles. They can rotate around and slide past and tumble over each other. And that's why we do have that shape changing. But remember, they still stay clumped together. That volume stays the same. They stay clumped together because some attraction still exists. It's only weakened. Now, once again, if we were to take a liquid and add some heat energy to it, those particles are going to move even faster. They're going to begin to collide even more violently, which is going to push them even farther apart. And at that point, once we have this much heat energy and these violent collisions, these particles are going to get so far apart that the IMF is completely gone. These particles are completely free. There's no attraction between them. And once we have no attraction, once we have enough energy to push them far enough apart to have no attraction, that means that we now have a gas. Now, when we look at gases, we know that these obviously are particles that have a lot of heat energy. They have a lot of motion. The particles are very far apart. They have no attraction, and they're free. They just bounce around randomly at high speeds. So, when you think about gases being able to change both shape and volume, well, this is why. That no attraction, which was caused by that gaining of heat, is what allows these particles and the gases to be able to change shape and volume. Now, there are other phases of matter between solids, besides solids, liquids, and gases, but we are going to ignore those. Um, so let's just think about what would happen if a gas began to lose heat energy. If a gas begins to lose heat energy, well, of course, those particles are going to slow down again. They're going to collide less violently. That's going to allow them to move a little closer together. And those attractive forces are going to reform. And those particles, now that they're attracted to one another, um, the substance is going to begin acting like a liquid again. And really, guys, sort of this idea of solids gaining heat and moving to liquids and then gaining more heat and moving to a gas, these changes that we see, the substance doesn't change. Right? This is still, if this is water in this inside this seal container, this is still water. It's just that form, that state that changes as we add or we lose heat energy. All right, guys, that's 9 minutes. That's it for today. I hope you guys have a wonderful day.